Yeah, that coefficient of determination is the R square that we were referring to, and the portion of the total variation in the dependent variable that is explained by the variation in the independent variable. In the sense, if you see the coefficient of determination value, it represents the variation that is present with respect to the x and y values respectively. And the coefficient of determination is also called as R square, and it is denoted as R square. Yeah, and how to calculate the R square, we were already looking into that part, right? So we saw that it is a ratio of SSR by SST, the regression sum of squares by total sum of squares, and it has a range. So actually it's a ratio, right? So it has a range between 0 to 1. So this is how we are going to calculate the R square value. And with respect to the R square value, how we are going to interpret the relationship between x and y. So if the R square value is perfectly 1, then it's a perfect linear relationship between x and y. 100% of the variation in y is explained by variation in x. That is what the R square value mean or signify. And suppose if it is 0 to 1 between the range, then you have this weaker relationships between x and y. So you can see the scatter, right? So there's no strong relationship, but there's a weak relationship that exists between x and y. Some but not all of the variation in y is explained by variation in x. That is what it meant. And if you see the R square value at 0, then it signifies you that there is no linear relationship between x and y directly. The value of y does not depend on x, and none of the variation in y is explained by variation in x. That is what the value of R square generally signify, and it acts as a metric for understanding the quality of the model, regression model that you have made. And coming to the standard error of estimate, the standard deviation of the variation of the observation, which is around the regression line, in the sense like standard deviation of the variation of observations. So whatever the variation of observations are there, if you want to find the sigma of that, in the sense like the standard deviation, then you are going to calculate with respect to this s of yx. And you can see like it is a square root of the SSE by n minus 2. So using this, you are going, n is nothing but the number of samples, our sample size, and SSE is the sum of squares. Using this, you are going to calculate the standard deviation part. And how we are going to compare the standard errors, as we were discussing, like SYX is a measure of the variation of the observed y values from the regression line, right? Yeah, it's a variation, and you have the small yx, small syx and large syx. If the variation is large enough, you can see the scatter, or there is no strong relationship between that relationship that is existing between x and y. And if you see the small yx, then you can see that the samples are closer enough, right, to each other. So you can see there's a strong relationship that is existing between x and y. The magnitude of syx should always be judged relative to the size of y values in the sample data. That is, syx equal to is moderately small relative to house prices in the range. So yeah, with respect to the syx, also we are going to judge it with respect to the y values in the sample data. And what are the different assumptions of regression? So if you want to remember that, there's an acronym using which you can remember that it is line in the sense linearity. So there are some assumptions that we are going to make when you're dealing with the regression part, particularly. So first thing is linearity is nothing but you should have an underlying relationship between x and y. Whatever the relationship is there, it should be linear. And independence of errors, in the sense like whatever the errors that you are seeing, they should be statistically independent to each other. And there should be a normality of errors, in the sense like error value should be normally distributed for any given value of x, and there should be equal variance. Homoscadacity is nothing but if you see if you have a probability distribution of errors and it has constant variance, whatever the distribution of errors are there, right, if it has constant variance, then you can refer it as this homodiscanity.